Okay, so good evening, everyone. So we'll be starting with our lesson. Today's session is about implementing host and software security. Okay, so this is our fifth topic or chapter. Yeah, chapter number 5. Yeah. Hindi makita yung presentation. Just give me a minute. Okay. Okay, everyone, can you see my my presentation? Okay, good. So yeah, I'm recording this session as well. So today's session is about implementing host and software security. This is our chapter 5 in Security Plus. Here we will learn about implement host security, implement cloud and virtualization security, then implement mobile device security, and finally incorporate security in the software development life cycle. Okay, now first we'll talk about the hardening, yeah, which is the security technique of altering systems configuration to close vulnerabilities and protect the system against the attack. So for example, if you're using, let's say, servers running Linux or running Windows, we could actually implement hardening by disabling unnecessary services and to make sure that we are adhere to or conform to security policy. For example, if you have a web server, this web server needs to only open port 80 and 443, meaning that the remaining ports should be disabled. Yeah. So we need to make sure that our server or servers opens only the authorized ports. Yeah. And there are many different techniques available. Yeah. Remember that when you do hardening, it might also restrict system capabilities. Yeah. Meaning that some of the software or application may not run correctly because of the tight or restricted system capabilities. And you need to make sure that hardening must be balanced against accessibility. Yeah. Meaning that although you're doing the hardening to make sure that your servers are protected or secured, you also need to make sure that people can still access the software or the application smoothly. Now, when you talk about the operating system security, each operating system has unique vulnerabilities for the attackers to exploit, right? When you can have like Windows, Linux, Macintosh, yeah, and different OS will have their own weaknesses, and different vulnerabilities might be exploited by the attackers. So staying up to date to make sure that you have the latest patch or patches provided by vendors is also one of the things that you need to maintain. Yeah. And different type of operating systems such as network, server. We have servers, of course, the workstation, operating system running on your Cisco devices, Juniper, yeah, they have their Jun OS, yeah, Cisco iOS, appliances, even mobile, yeah, like Android, iOS, yeah, and Windows CE, like running on your ATM machine, yeah. Those are the operating systems, and they have their own vulnerabilities that might be exploited by the attacker. Yeah. Now, hardening techniques. There are many different ways of doing the hardening. We might start by implementing principle of least functionality, meaning that you only allow certain functionalities to actually be used by the user, or disabling unnecessary network ports and services, which are normally related to application as well. Take advantage of secure configuration, maybe disabling default accounts like, you know, guest account, admin account. You create your own new account that might be needed for your administrative, related management, or even like forcing users to change default password, as well as implementing patch management service. Yeah, that would be the examples of the operating system's hardening techniques. Yeah, so the remember that the main objective of a system operating system hardening is not to close everything, but just open what are required by the policy of your organization. Yeah. And then some theoretical topic about trusted computing base. Yeah, so we have trusted computing base, the hardware, firmware, and the software components which are responsible for ensuring computer security. So it's not only about the software, but you need to make sure that your hardware, your firmware, and any other components support your, system security. So this is how it looks like. Yeah. Trusted operating system that fulfills security requirement as in a TCB, or trusted computing base. So we got like the hardware, the firmware, as well as the trusted OS. Trusted OS can be anything. Can be Windows, can be Linux, can be Mac OS, as well as Android, and let's say iOS. Yeah, Apple iOS. Now, talking about the hardware and firmware security, we have different components that made up the hardware and firmware security, starting from your BIOS, yeah, the basic input-output system, and the unified extendable firmware interface, or known as the UEFI. Yeah, and UEFI is the more modern and secure. Yeah, the older one was actually the BIOS. We also have the root and trust of the HSM, hardware security module. Like, for example, the root that trusts the encryption on your machine. Yeah. Security module that stores the information on your operating system, as well as on your hardware. There's also a TPM known as the Trusted Platform Module. You can actually check whether your computer or your laptop or your PC supports the TPM. If you want to see if, let's say, your laptop has TPM enabled and installed, you can actually, in fact, run, let's say, maybe like, I forgot the name, you know, the BitLocker on Windows 10. If you can enable your BitLocker on Windows 10, it actually shows that your laptop or your PC or your computer has the TPM enabled. Yeah, and that is actually used by the the operating system to store generated keys. Yeah, to be used in TCB. Yeah. So the TPM is a hardware module that is actually stored and implemented, I would say, placed on your laptop's board, that will allow you to store any cryptographic related keys. Then we have the secure boot and remote attestation, which is actually the secure boot that allows you to prevent malicious processes by executing during the boot. Yeah. Which is normally also take advantage of the use of TPM. Yeah. So cryptographic has taken a bootloader to ensure integrity. Yeah. So we also have other components such as FDE/SED, full disk encryption, and self-encrypting drive, which allows you to encrypt the storage at the hardware level and normally avoid attacks targeted at software-based encryption. And we have others like EMI protection, electromagnetic interference that can leak data from hardware, as well as the EMP protection, which is the electromagnetic pulse that will also allows you to protect from those attacks, yeah, like the encryption related attack. Okay, now how about the security baseline? Yeah, I hope that everyone can actually follow this. Just give me a minute. Okay, so we have about 27 participants now. That's great. Yeah. So how about security baselines? Now, what is actually, or what are security baselines? Security baselines is a collection, or I would say a collection of the hardware, the host security settings, which is normally compared to the security setting as on your network or on your host. So a baseline are very crucial for streamlining the host hardware process. Yeah, like for example, you can create a security baseline for Windows 10 workstation. Yeah, and it might also differ based on the computer's function and the operating system. So you can create something like, think about creating a baseline, a very minimum or minimal security settings that would be implemented on your host, which could be your server or your client, yeah, or could also be something like for your router, yeah. So when you create a baseline, you can compare your current server configuration and check whether this particular configuration is correct or not, yeah. So for example, you can also create a baseline for all of your web servers, yeah, that only would allow port 80 and 443. So something like that, yeah. So normally we create baseline based on the computer roles or roles of that particular computer, yeah. Let me give you an idea about this. Just give me a minute. Yeah, so okay, just give me a minute. Let me show you my screen. Okay, let me see. I think I will give you demonstration on this on my PC or my laptop. So let me show you my screen. So can you see my MMC? This one? Tell me. My MMC console one. Can you see? Okay, good. Now, yeah, so imagine if, let's say, you have this MMC. All you need to do is just type MMC on your command prompt, and then here, MMC is the Microsoft Management Console. So what you need to do is you will add the remote snap in, yeah. And what you will need to add is the group policy. So for example, this one, local security policy, or maybe like group policy object editor, yeah. And this will actually show you the configuration on my laptop or on my Windows 10, okay? So if you double click or you expand the local computer policy, you could actually find this administrative template, right? Yeah, here, and we can also go to the systems and so on, right? You have the computer configuration as well as the user configuration, yeah? So normally you could actually export this, yeah. So you could actually export this by using, let me add extra add-on, yeah, which is actually known as the group policy management, yeah, group policy object editor. I think this is already, yeah, group policy. let me see, group policy object editor. This is the same one. Okay, anyway. Let me remove the snap in so I won't be confusing. So anyway, so let's have a look at the computer configuration. Yeah. So we have this computer configuration and user configuration. What's this? Okay. So here you can actually double click Windows settings. Yeah. And you see this one? Underneath this Windows computer configuration, so local security policy, computer configuration, Windows settings, security settings, we have the local policy, right? So here, so you can right click and yeah, I remember that you can actually go to this one. Yeah, here under the or just click on the security settings. We can actually export the policy. Just try to you know, demonstrate something. So for example, like this is my default default Windows 10 policy. Okay, so I'm saving my current policy as default Windows policy, right? Or maybe yeah, let me just export it to just put it as default Windows 10 policy. Okay, save it. Now, let's just try to modify something. Like, for example, the password policy, I will set enforce password history to, let's say, 5, password remembered. And maybe password age, length, maybe like I will just put 8 as well. And you can also enable like password must meet the complexity, enable, yes, okay. And then also, let's just change something, some others like account lockout duration, yeah. I don't have the, yeah, I can't change this maybe because of the threshold. Okay, so for example, I will just put like 3 logon attempts and so on, yeah. So it will automatically change this for me, yeah, account duration, okay. And maybe audit policy, let's just set to, let's say, audit logon event, success, failure. Then we can set, okay, audit object access, success, failure. Yeah. So just do some modification on this one, as well as privilege use, for example. Okay. So I made some changes on my local computer security under the security settings. Remember that I have just exported my default settings, right? So what I can do is, if you're talking about the baseline, you could actually use this as my baseline. So for example, here, I'll export this as my baseline, Windows 10 baseline. Okay. Okay, now let me import my previous default settings. Yeah, for example, import my default. Yeah. Yeah. Once I import it, everything will be back to normal. Yeah, so 0 password remembered. Earlier, I changed this to 5, if I'm not mistaken. Yeah, and also others like this one, all no auditing, right? So you can actually add the other snap in that will allow you to, yeah, let me just add computer. There's, I remember there's one snap in called security something, security configuration and analysis. So I'll be using this, yeah, here. So what I will do is I will open or create new database, open database, so sorry, open database, and I will put something called test DB. Yeah. Now, here I can import the template, like for example, my Windows 10 baseline, yeah. And then from there, you can analyze your computer now. So when I imported my, so I can actually import again, import the template from the Windows baseline, okay? My current situation, I mean, my current Windows 10 policy that I'm actually using is default Win 10 policy. So when I can actually use this to compare my current policy with the, what do you call this, the imported policy. So just to see what are the difference, yeah. So you can select Analyze Computer Now and select the error path, and then, yeah. You see, if you open up your account policy, you should see, yeah, you see, can you see the enforced policy history? My baseline is supposed to be 5 password remembered by but my computer setting only uses this default setting, which is 0 password remembered. So it will actually tell you, which particular policy, or I would say, yeah, which particular setting or settings are not, or is not the correct one. So it will tell you, what do you call this, the difference. So see this one, enforced password history. My baseline was set to 5 password remembered, while my computer settings was actually set to 0 password remembered. How about minimum password length? Yeah, database setting, which is coming from my baseline, 8 characters for minimum password length, while computer settings set to 0 characters, as well as the complexity requirements. Yeah, you can also check other type of policies like local policy, audit policy. See this one? We got audit logon events, not according to the policy. Excuse me. And you see the check mark as well as the cross. Yeah, cross meaning that your computer settings or your computer setting does not actually follow the baseline. So that's how you use the baseline. So you can actually import this baseline, and then if you want to make sure that this computer follow your baseline, what you need to do is you just click on the security configuration analysis, right click, and then select what do you call this, there's an option to yeah, we did the analyze, and then you can actually just use this to yeah, I remember there's an option to actually take advantage of this, yeah, but let me see, analyze, okay, that's it. And then yeah, you can import and export just to make sure that the policy being implemented is according to your baseline. Okay, so when you imported the policy into this computer, you can just go to the computer configuration, Windows settings, security settings, yeah, right click, you can just import your Windows 10 baseline. Yeah, so when you imported this, it will actually take the effect and change the security configuration on your computer. Okay. Now let's move on to other. Yeah, can you see my presentation now? I'm back to my presentation just to make sure. Okay, good. So let's move on to the next topic. So software updates. Okay, I believe some of you are quite familiar with the software updates. We know about the patch. Patch is one of the update types available. A small unit of code meant to address a security problem or functionality flow. And then we have the hotfix, which is normally a patch issued on on an emergency basis to address specific security flow. So if there's any emergency patch that is needed to be implemented or being implemented, then you have to use the hotfix. Yeah, normally related to security. Yeah. So there's a security flow, like for example, SMB, Windows SMB has a flow, then you need to apply hotfix rather than the patch. Yeah. Anyway, a hotfix is also the patch. Yeah, not the entire patch. Yeah. Then we have the roll up, a collection of previously issued patches and hotfixes, as well as the service pack, which is a large compilation of system update that can include functionality enhancement and any prior patches, hotfixes, and roll ups. So I would suggest that you keep, updating your, server or your operating systems, your clients, just to make sure that they have been fully patched. Yeah, just to avoid any security related breaches. And then we have other types of application blacklisting and whitelisting, which is actually related to the hardening. So blacklisting meaning that you're preventing specific applications or even all application which are on the list of unauthorized applications. So for example, you only you do not allow, let's say, a particular application like such as TeamViewer to run, let's say, on your Windows. Yeah. So when you set up this operating system not to run specific application, in this example, the TeamViewer, that is called blacklisting. Yeah. And the drawback, the weakness, you can't block malicious application you haven't identified. So you need to make sure that you can actually identify the application before you can actually block it. And there's another one called blacklisting, which is preventing the execution of all applications that are not on the list of authorized applications. So whitelisting is better than blacklisting. Because you can actually tell, okay, I'm authorizing this particular application. So drawback, creation and maintenance of lists increases overhead. So I would personally choose the whitelisting rather than the blacklisting. Yeah. Okay. Now, logging. Part of the operating system is the logging, which is the process of the OS or application to record data about activity on computer. Yeah, so you can have, like, operating system logging by you can actually review the what do you call it, the logs by opening Windows log through Event Viewer. And logs normally stores information about anything about the logging. I mean, about the process, like audit success, failure, as well as the start and the stop of specific services. Yeah, and logs can also be used to reveal information about suspected attack, because remember that logs, yeah, like Windows logs or application logs, actually stores a lot of things. Yeah. And logging, the logs can be used as the detective security control, which also allows you to find suspected attack or malicious behaviors. Okay. Now, auditing is performing the organized technical evaluation of a security system security to ensure it's in compliance. So we normally do validation by auditing the system. Yeah, it's actually similar to security assessment. In fact, auditing might also be part of the security assessment. But auditing focuses more on making sure that the system meets the set of criteria. Like you can actually check the management related security controls, technical related security controls, as well as the operational related security controls. Yeah, so it will check regulations, standard laws based on specific requirements, such as PCI DSS, ISO 27001, and most audit will be performed by third party unless you have your own internal auditing team. So for example, external auditor checks to see if an online merchant is in compliance with PCI DSS. And commonly also related to reviewing logs, your password, firewalls, as well as permissions on specific operating systems or yeah, application. Yeah, audits also contribute to the overall hardening process. So the result of the audit would actually assist you on, you know, providing the or improving the security posture of your organization. Yeah. And then, of course, you know about the anti-malware software, which is normally used to scan system for malicious software. I myself is using, I'm currently using Bitdefender as well as Malwarebytes, just to make sure that my laptop is fully protected. Yeah, so you can use any type of anti-malware software available in the market. Yeah. And the types of anti-malware includes antivirus, anti-spam, anti-spyware, pop-up blocker, as well as host-based firewall. Yeah. Just to give you an idea that I am actually using this. Yeah, let me just open. Yeah. So I'm currently using this. Yeah, so let me just minimize. So I'm currently running the, just give me a minute. Yeah, so I'm running the Bitdefender. Yeah, so I'm running this total security. Yeah, I am also using the Malwarebytes. Yeah. So anyway, you have the option to actually use any of the available software. Yeah. All right. So I'm back to my slide. Anyone can see my slide? Everything is okay? Just checking. Okay, good. So you can use or you can purchase antivirus, a free version, or, you know, commercial edition, and then anti-spam. You can actually you know, get something. Let me just open up. Yeah, so you can use like this one, Malwarebytes. I would suggest that you use this, you know, this Malwarebytes. Yeah. This is also a very good and recommended tool for anti-malware. And I'm currently also using Bitdefender. Internet security, yeah. Okay, so you can use this Malwarebytes and Bitdefender security. And if you want something free, you can actually use this Komodo antivirus. Yeah, this is a very good free antivirus. Yeah, yeah. So it's up to you. Yeah. By the way, if you're running Windows 10, Windows 10 has a default Windows Defender, which is also the anti-malware software. Yeah. So let me get back to my presentation. Okay. And how about hardware peripheral security? Yeah. Peripherals includes wireless keyboard, your display, monitor, external storage devices, printers, as well as other type of memory, then cameras and microphones. Each of these peripheral has their own weaknesses or vulnerabilities. That's why it is actually important for you to also pay attention to protecting this kind of peripherals. Yeah. For example, here, wireless keyboard and mice. Attackers may send force input to wireless receiver. Research device known to be vulnerable, and you need to make sure that you stay current on firmware updates. So in even your cameras or your mobile phone, yeah, they are prone to attack. So I would really suggest that you do the updates and make sure that your operating systems of your laptop, your PC, your computer, your Android, as well as the iOS are fully patched. Yeah, get the latest patches from the vendor. Yeah. And then how about embedded system? Hardware and software system that have specific function within a larger system is known as embedded system, and usually do not have the complexity of a PC or a server. Yeah, may not have GUI, but still have the OS and less sophisticated. Yeah, like for example, whatever inside your camera, or maybe your PLC. Yeah, or maybe something inside your storage drive. Yeah, these are considered to be embedded system. Yeah, so they have their own technology. Yeah, so home appliances like your TV, your what do you call this, smart TV, and other industrial machines. Yeah. Some implication in terms of security for the embedded system, including ICS. ICS stands for the Industrial Control System, or also known as SCADA. Like for example, the PLC, yeah, controller. That is an example of the ICS or SCADA. And if you have watched this movie called Black Hat, you might be able to see how ICS or SCADA system being planted in a nuclear, industry or nuclear plant, being hacked by the hacker. Yeah, so they have their own, system that is normally used to support critical infrastructure, such as the nuclear plant, oil plant as well. Yeah. Then we have the microcontroller, consolidate CPU, memory, and peripherals in one component. Yeah. Then RTOS, which is the real-time operating system, specialized type of operating system. I haven't really seen this RTOS or real-time operating system, so I can't really tell you much about that. Yeah. Okay, now we also have smart devices, like for your network connectivity, electronic devices, your computing on autonomous computing properties. Yeah, anything like your TV. Yeah. Then IoT, you know about the IoT, the Internet of Things devices, which are object electronics or not connected to the internet. Yeah, like your smart devices with very poor non-existent security. Then we have camera system, your CCTV. They have their own standard operating system, and then also the special purpose systems like ATM, medical devices, and vehicles. Yeah. Now, there are some guidelines for securing hosts. Yeah, so you need to make sure that stay up to date on the vendor security information. Yeah, try to apply the best security settings by implementing the security baseline for your operating systems, as well as your devices and security appliances. And then you can actually use the logs to, look for any suspicious behaviors or malicious activities, and you can actually do audit to make sure that you comply to specific compliance requirements, such as PCI DSS, ISO 27001, and so on. And you need to consider also security implication of a unique systems, such as the IoT, ICS, or SCADA. Okay. As well as the embedded system. Yeah. So let's perhaps skip this one. We can actually do the activity on ourselves. Yeah. So the activity is very simple. You might want to just review the logs for any cracking attempts. Yeah. So we might just skip this activity. Yeah. And also hardening the server, yeah, by disabling services. So how do you disable services? It's very simple. In Windows or on Windows machine, all you need to do is you go to the services and you can select disable service or stop the service. Yeah. Okay. And then how about virtualization? Yeah. Your VMware workstation, your Microsoft Hyper-V, or even like this VirtualBox, they are virtualization. Yeah, they are the form of virtualization, creating a simulation of computing environment that simulate hardware and software. Yeah, and virtual machine is a virtualized computer. So this is also known as the guest OS. Yeah. So when you run Windows 10 with VMware, for example, and on VMware you run, let's say, Linux or Kali Linux. Kali Linux is known as the virtual machine, and this virtual machine is also known as the guest OS, guest operating system. While your Windows 10 that runs your VMware is known as the host operating systems. Yeah, so you can actually run multiple operating system by utilizing VMware, VirtualBox, as well as the Hyper-V and any other type of virtualization, such as parallel desktop on Mac. Yeah, so those are the examples of virtualization. And just to give you an idea that virtualization is a very simple form of sandboxing, which also allows you to protect the what do you call this, the security of your virtual machine, whatever inside your virtualization container. Yeah. And then we have the hypervisor layer of the software that separates virtual software from physical hardware it runs. Yeah. And we have the type 1, yeah, which runs directly on host hardware. For example, Microsoft Hyper-V or VMware server. That would be the example, or those are the examples of type 1. This is known as the bare metal hypervisor or bare metal virtualization. And the second type is, or type 2, runs application on top of operating system. So when you run like Windows 10, when you run Linux operating system and other type of operating system with your host machine running Windows 10, that's also that is actually considered to be type 2. Yeah, type 2 is user-based virtualization. Yeah. So type 1 does not actually need any operating system on top of it. You just need to install the operating system as well as the hypervisor by themselves. Yeah. So very good example is Microsoft Hyper-V and VMware Server. And very good example of type 2 would be the VirtualBox, VMware Workstation, as well as Parallel Desktop. Yeah. So this is type 1 and type 2. As you can see, that type 2 requires host operating system to host the hypervisor, while type 1 does not require you to have the host operating system because hypervisor is already built in. Yeah. Now, we also have others like virtual desktop infrastructure, which uses virtualization to separate personal computing environment from the physical machine. And the virtual desktop environment, in fact, is the virtual machine running on the VDI or virtual desktop infrastructure. So it allows you to manage, your PC, your workstation. You can easily deploy your virtual desktop environment on many different machines. That would also help you to mitigate the costs associated with the physical computer, meaning that you don't have to buy or purchase a lot of workstation just to do the work for the users. All you need to do is, deploy the VDE, virtual desktop environment, so that the user can just connect to the VDE to do their work. And several security implications related to virtualization include your patch management, ensuring all patches are installed on your VM, least privilege, just make sure that you only give access to those that need them. Also, the logging, make sure that everything in your on your VM are logged. Networking, unique configuration, virtual networking devices. Also create the snapshot or a state of the VM, or capture the state of the VM on certain points of time, just to make sure that when you want to restore it, you can easily restore it. Just like taking snapshot is just like backing up your VM. And then we have others like VM sprawl avoidance to make sure that you can actually avoid the sprawl, which is actually related to what do you call this, security. I'm not really sure about this. You can actually check about the sprawl avoidance. It says that a compromised VM could slip by your notice, yeah, and incorporate VMLM or VM sprawl avoidance will avoid sprawl. Please do some reading on this. I also need to, check what is actually this VM sprawl. Some of the terminologies might also confuse you guys or even me, because they always have different terminologies and things like that. And then we have the VM escape. I remember that VM escape allows the VM to actually access resources outside of the guest operating system and interact directly with the hypervisor. Yeah, it's very what do you call this, dangerous. Yeah. Then we also have the cloud computing, which is actually based on the virtualization, involve real-time communication over large distributed network to provide, different type of resources to customers. Yeah. So, for example, like they can provide the e-commerce application by hosting the applications on the cloud or in the cloud. And if you want to focus on the core business, I would suggest that you use the cloud computing to make it easier for the business. Yeah, because a lot of e-commerce websites and e-commerce organizations nowadays are utilizing cloud computing. And we have models like deployment models, private, yeah, meaning one single entity only. Public, meaning that you're actually sharing to other customers. Community, meaning sharing, but a specific to the specific community. And you can also use the hybrid, which is a mixture of private cloud and public for the customers. Yeah, that would be the cloud deployment model. Yeah. Then services type includes software, known as the SaaS, software as a service, just like Office 365, Salesforce, G Suite, yeah, Gmail, or Google Doc. And then we also have the platform, yeah, which is actually PaaS. Someone is raising hands. Any question? Let me know on Telegram. Okay, so none. Can you see my presentation? Hello, guys. Okay.
Yes.
Yeah. So all right. So let me just continue. So we have the software as a service, platform as a service, just like Oracle database, Azure SQL database, Google application engine, which provide virtual system to the customer, while SaaS will provide the application to the user. And then we have the infrastructure as a service, which provide access to infrastructure needs. Think about having your, outsourced data center, yeah, like Amazon EC2, Azure, VMs, OpenStack. And we also have something called security as a service, which provide resources for security purposes, such as Cloudflare, FireEye, SonicWall, and they provide authentication, anti-malware, intrusion detection, etc. Yeah. Then these are some guidelines. Yeah. So consider using virtualization and make sure that your virtualizations operating systems on your VM are fully patched. Even your what do you call this? Your hypervisor, just to make sure that vulnerabilities related to virtualizations are what do you call this? Being controlled. Yeah. So yeah, logging is critical. Least privilege is also very critical, just to make sure that you are fully protected, whether you're using physical system or virtualization. Yeah, and consider uploading some of the operations to your to cloud. Yeah, cloud service providers. Yeah, as well as the security as a service providers. Yeah. So nothing much about the activity here. I'll skip. Yeah, we might want to do the you know uh, activity later on. Yeah. So other than that, we have mobile device connection method. You know about the cellular, yeah, which is the GSM. Then Wi-Fi, yeah, Bluetooth, then NFC, yeah. So I'm pretty sure that you are quite familiar with these connection methods. So if you have any question, yeah, let me know. Yeah, the most commonly used is cellular, Wi-Fi, Bluetooth, and NFC. NFC is normally used for what do you call this? Like when you do the topping, yeah, for let's say some cards, yeah. It might also looks like you know, RFID. Yeah. So we have infrared, SATCOM, and USB. Yeah, nothing much. Yeah, just do some reading on this. And of course, mobile device management, which is normally a web-based platform with centralized console, which allows you to track, control, and secure your organization infrastructure. Specifically, if you have like BYOD or bring your own device, which allows you to bring your mobile devices uh, into the organization. Yeah. So it will allow you to, this mobile device management, or MDM, will allow you to enforce security on all mobile devices, yeah, at once rather than individual. And we have several security controls such as screen lock, strong password PIN, full device encryption, remote wipe, lockout, geolocation, geofencing, access control, application, and content management. An example is the remote wipe. So if let's say your device, your handphone, your cell phone got stolen, you can easily remove, wipe your cell phone remotely. Or maybe like geolocation, geofencing, which allows you to track the geographic location of the devices. Yeah. Okay. And well, I can give you some idea about some security controls. Yeah, let me just open up this one. Yeah, so okay, just give me a minute. So let me show you my screen. Yeah. So I'm actually using this tool, very simple tool for geolocation. Yeah. So I'm running this follow me. I'm using follow me. I can actually look at my map. And this follow me allows me to track the existence of my phone. Yeah. So it's something like this. Yeah. Yeah. Of course, if you have, you know, this follow me has several versions. You can actually get the follow me Android. Yeah. Yeah, this one. It supports iOS and Android. Yeah. And you can even use the free service of this follow me. Beside, of course, beside, like say, find my phone on, let's say, what do you call this? Apple, yeah. So on Apple iPhone, we have this feature called Find My Phone, right? So if you don't have this Find My Phone, you can actually use this Follow Me. Yeah. All right. So let's get back to our lesson. Other than that, we have security control, asset tracking, and inventory control, push notification, which allows you to centralize the sending notification, limit removable storage capabilities, storage segmentation, which allows you to divide data storage. Yeah. Then we have the containerization, which allows you to isolate sensitive application and storage from others. And several mobile operating systems comes with this functionality by default, as well as disabling unused features. So these are part of the mobile device security controls. Yeah. And for the enforcement, we have application installation from third-party storage, stores, application site loading, meaning that you can actually download and install application from the unofficial, outside of the official store. And then you know about the rooting and jailbreaking, right? Rooting is normally gaining root privilege on Android, while jailbreaking is the same one, removing software restriction on iOS. Yeah. Apple iOS. And we have custom firmware configuration, OTA updating the on-the-air, updating carrier unlocking, as well as camera and phone use, yeah, microphone use. So you can actually do some checking on those. Yeah. And then we have the geotagging, internal, external media use, SMS, MMS use, Wi-Fi direct use, tethering, you know about this one, right? If you want to share your internet connection, you can use tethering, yeah? As well as the payment method, which is normally related to payment services available for mobile phone. Yeah. Deployment models include corporate owned, meaning that the organization will give you, the access to the phone, and normally organization will give you the phone, and it will be strict. Yeah. We also have bring your own device, meaning that company owns, and you can also manage personal devices. But of course, we need to control those devices by implementing a mobile, security management. CYOD, yeah. Choose your own device, enables employee to choose from vetted list of devices, and employees still control the device. Yeah. While COPE, we have the corporate owned, personally enabled, meaning that everything will be owned by the organization and they have some control, as well as the VMI, which is virtual mobile infrastructure, which is similar to VDI or virtual desktop infrastructure, but uses mobile operating systems. And for the bring your own device means that the employee or employees can actually bring their own devices, but those devices will be under, or maybe like half of the features will be controlled by the organization or company. And for the security control, we can implement the policy, the owner decision, patch management, architecture, forensic, and privacy support. So yeah, of course, when the company allows you to bring your own devices, they need to know, and they need to have certain controls over your devices, because they might have the policy, like for example DLP, the data loss prevention policy, that will not allow you to transfer their sensitive data to the outside world. Yeah. And some guidelines on this implementing device security. Yeah, BYOD is very crucial. You need to have the policy to control how mobile devices can be used in your organization, and you need to enforce the mobile device security by implementing the device management platform. Yeah, so you can actually get some idea of how we can actually implement the device management platform by using many different software available outside. Yeah. Okay, so let me see. And then the last part will be the software development life cycle. You should know about this one as well. The practice of developing software across a life cycle from initial planning to final deployment and obsolescence. Starting from the initiate, design, implement, testing, deploy, as well as dispose. So each developed application goes through distinct phase. You might also use different methodologies such as agile. But this is just an example of the commonly used software development lifecycle, or SDLC. And as I already mentioned, some organization might use agile, which focuses on adaptive measures for the phases. And here, deployment team can more easily respond to the changes. Tasks broken up incrementally, and then useful for complex, unstable project when you have like very fast changes, rapid development, frequently releasing new untested code. Very hard to do the testing. While waterfall is very good for, slow and static, development method. 5 phases: initiation, design, implementation, verification, testing, and maintenance. Very suitable for very major project or big project. So smaller project, I would suggest agile, but a very big project, I would suggest waterfall. And then we came up to DevOps, which is the integration of software development with the system operation. So basically, DevOps represent a cultural shift from the organization, and the goals are to improve speed and reliability of those operations. So for example, here, development team is building an application with network functionality, so they need to work with the operations department to make sure that they provide the best of their site. And it demonstrates continuous integration, and also support this DevOps support security automation such as rapid configuration and baseline. And we normally talk about the infrastructure as a code, which is normally would allow you to integrate programming and scripts and automation into our DevOps, right? And nowadays they came up with the DevSecOps, which is actually the integration of the software development, system operation, as well as the QA and security. So we also have something called DevOps and DevSecOps, which integrates the security into the development process. And here in SDLC, we have the versioning, which is the practice of ensuring that changes to the project assets are closely managed in discrete version. So we normally use things like GitHub or SVN or something like that, which allows you to make sure that any security issues will be addressed correctly, and developers can easily divert to earlier version when it is needed. So for example, here from version 1 to version 2 to version 3 should be properly stored or properly documented. And then secure coding techniques. Secure coding techniques refer to the techniques used to secure our application by removing or by implementing the secure coding best practices, such as this one. There are several techniques we can actually use, like properly do the input validation, properly do the error handling, just to make sure that all funny characters or strange characters will be removed. It will not actually create a bad input data, because it will actually create problems with our application. Also, error handling that will allow you to control the error, which will not reveal too much info that would be used by the attacker to hack your system. And then we also have others like encryption, which is very sensitive to, very vital for securing stored and transmitted data. code signing, which is actually for authenticity of the software, authenticity and integrity. Yeah, just like Microsoft, they have their own code signing. When you download a software from Microsoft, you will see that this particular software is being signed by Microsoft. So any attempt to change the code or to change the executable file will be detected, and it will make sure that the code is authentic. Yeah, and then we also have others like obfuscation, which is the process of hiding code. Yeah, can also mitigate reverse engineering attempts. So remember that obfuscation is just to, is a process of, encoding or scrambling the code so that it will be harder to read, harder to understand the logical behind the code. And we also have others called code reuse. Use existing secure code that has been verified and normally comes with the third-party libraries. Yeah. Other than that, we have limiting that code, which allows you to execute the code, yeah, and remove that code to minimize the risk. Server side versus client side, that would allow you to validate the input on the the front end application as well as the back end application. Limiting data exposure, just to make sure that application does not actually exposes data, sensitive data, to the users or to the attackers. Then memory management, like to make sure that there will be no stack buffer overflow and any other type of overflow. Consider the language, the use of language like Python, Java, rather than C or C++, because C and C++ are vulnerable to buffer overflow. Then the use of stored procedures, specifically to validate the input for the database related application. Yeah. Then for the testing, we can do like, if you want to make sure that your codes are free, or I would say are free of vulnerabilities, you can actually do or maybe limit the number of vulnerabilities. You can do like static code analysis, which is to review code, source code with scanners, the static code scanner. So your code needs to be reviewed, and your if you're using tools such as checkmarks, or maybe like Fortify, HP Fortify or Fortify, you can actually scan your code to make sure that your code or codes do not introduce security vulnerabilities. Also, dynamic code analysis, also known as the fuzzing process. Yeah. In fact, dynamic code analysis, meaning that you need to also look at the behavior. Unpredicted user input could be something like that. I mean, could be something that you could, I would say, test. Yeah. So we can also do a scanning on a website, like on a particular web application using a specific web application scanner. That would be the example of dynamic code analysis. Yeah. Then we also have stress testing, which is normally to evaluate how software perform under extreme load. And then sandboxing, as I already mentioned, virtualization is an example of a sandboxing technique. And model verification, which is to evaluate how project meets specification defined earlier in the development. Okay, so here are some guidelines for incorporating security in a software development lifecycle. So first, you need to make sure that you integrate the security into each phase of the SDLC, just like what Microsoft has done, and you can actually adapt to the different development methods, such as from waterfall to agile, and you can also consider adopting DevOps or even DevSecOps, and make sure that you follow all of the stages to make sure that the resulting application are robust. Yeah, they are robust and they do not really introduce many vulnerabilities. Yeah. So let me just give you one thing. So if you look at the Microsoft SDL, yeah, so let me show you so Microsoft, yeah, so let me just give you an example of this. So for example here, long time ago, Microsoft has started with their SDL, yeah, timeline. Yeah, SDL stands for the security development lifecycle. So they have their own SDLC, yeah, I mean SDL. Yeah, so let's check this out. Microsoft SDL best practices, yeah. So this is the Microsoft SDL, which is actually the a direct implementation of the secure SDLC. Yeah. So Microsoft call it SDL, or security development lifecycle. Consists of a set of practices that support security assurance and compliance requirements and help developer build more secure software by reducing the number of severity of vulnerabilities in software while reducing deployment development costs. So they start with this one, providing the training, defining security requirements, defining metrics and compliance reporting. They also do perform threat modeling, establish design requirements, define and use cryptography standard, manage security risk of using third-party components, use approved tool, perform static security analysis. This is the one I mentioned. Secure code review, also known as the static analysis security testing. They also do dynamic analysis security testing, also known as dynamic code testing. And penetration testing, which is also used to uncover potential vulnerabilities resulting from different things like code errors, system configuration vault, or other operational deployment weaknesses. Even if we have already done static analysis as well as dynamic security analysis, we still need to do penetration testing just to uncover anything that are not being uncovered during the static and dynamic. And then the last one is establish standard for the incident response. So yeah, you can follow this Microsoft SDL practices, the security development lifecycle. Yeah, very good example, because Microsoft has been able to, reduce the number of vulnerabilities. Imagine, let's say, from Windows 2000 to Windows XP, Vista, and now Windows 7 as well as, and now Windows 10. So Windows 2000 professional and servers, then Windows XP, they have a lot of vulnerabilities even after like 6 months of release. But since Windows 7 and Windows 10, we can see that the number of vulnerabilities being found when Microsoft released their products within 3 to 6 months have been reduced to very, very low. Yeah. So those are the result of Microsoft SDL practices. All right. So let's get back to our lesson. So this might be the last one. So, okay, then, yeah, we can't do this static code analysis, but you can check my video, YouTube video about how to perform static code analysis as well as the dynamic security assessment. So SAST and DAST, okay? Please check my YouTube for more what do you call this, real life examples of static code and dynamic analysis. Okay. Yeah. Any question, guys? Any question? Any question, guys? Yeah, I got 32 participants. Let me check. Yeah. So, all right. So that's yeah. If there's no question, you can tell me in your our Telegram. if there's any question, let me know in our Telegram. Just to clarify that we still on our chapter 5. Yeah, so we still have about 5 to 6 modules. Sorry, I can't. Yeah, just to give you an idea that this is the official PowerPoint slide by CompTIA, and I'm not allowed to actually share this SharePoint module. Okay, so thank you very much for your kind attention and your time to actually attend the lesson. Yeah. And see you in our next session, right? Good evening. Thank you very much and see you next time.